Okay, now we're getting into part 7 on this, on the pyramids, and want to show you how it's done. And he's actually showing you exactly how it's done. There's no question. You can check these numbers yourself off of different people's measurements themselves, going on the Wayback Machine all the way through. Let's just get into this.
Included the sock. So what you ended up with was 2 ways of measuring the pyramid's base. Well, which one was the correct one? Well, they were both correct. I think that they were actually intending to embody in there that there were 2 ways of measuring the pyramid's base. So what we have is the length of the base on the socle, which is the shorter of the 2 up there. It was varied from side to side. You'll notice 755 at the smallest to 756 just over at the largest. So there was some
55.5, just barely over 76. So there's less than a foot worth of difference in it. So everybody talks about how it's all lined up perfectly. Even in this picture, you can see that it's cut into 8 separate wedges, that there's a cross going the other way on that. But there's a little bit of offness that's on that too. And that's strange that there's some offness that's there, and he's going to show you connections to it. Now it goes on for about 8 minutes, and that's the reason I couldn't get it in the last one. So let's just try to go ahead and cut to the chase here a little bit. So on the outside socle, it's these numbers that are shown here. And the full perimeter is 3,043.433. So that sounds like a number we had just a minute ago. And he's going to write down these numbers here: 1080, 2160, 432,000, 864,000. Of course, we can go with 43,200 and so on that idea too. And there's a few other numbers that we had: 7920, 1440, and so on here. So now we go back and look at this. It's 481 foot tall, divided by its width, which just one of the measurements, or the in-between measurements, not the biggest or the smallest, but one of the in-between measurements, show you that it's really a ratio of 11 to 7, which is another thing showing you that there's sacred geometry that's built into it. That's why we have 7-11. Well, it was originally supposed to be open only from 7 in the morning till 11 at night, but then they went 24 hours, but kept the name. Let's continue though. As we look at this though, what are we looking at? Well, 755.85 is the measure we're looking at. First is the height. And so the difference between the height and the width on this is exactly the difference of height and width that is on Earth itself. And have you ever heard the story that if you took all the landmass of Europe and Africa and the Far East and put it all together and said, well, what's the center of all the landmass? It pops it up right there in North Africa at Egypt. And it's incredible. It just keeps going. So Cole's height set these numbers here at 482.7575.
So we can see how these numbers link the two. We take 1 square degree of latitude and longitude at the equator. Okay, we're standing at the equator. Okay, we know the polar radius now is 13 miles less than the equatorial radius. So what that means is that the circle this way is shorter than the circle. The biggest circle that defines the Earth is the equatorial circle. So a degree of measure on the equator is going to be the biggest, the longest of any degree we measure anywhere on the Earth, the equator. Okay, the north-south is going to be a little bit shorter. And you'll notice right there, we've got 68.7 miles north to south and 69.17 east to west. So it's not a perfectly square unit, is it? It's a little bit distorted. Well, that distortion is totally significant because it's that distortion that is a measure of the Earth's departure from being a perfect sphere.
And it's looked at as that this was done in a maritime way, that once they figured this out, like the ancient Phoenicians that we heard about, or much prior to them, or pre-Proto-Phoenicians, if you will, were able to figure out that whenever they went across the Mediterranean, that the constellations weren't in their same place, they were slightly different. And in doing that type measurement, along with an idea that's done through a sextant type of object, rather than these two sticks and one shows more shadow within each other, can give you an idea of where you're at. But supposedly we couldn't until we had a modern chronometer hooked up through Kronos, the god of time. Before we had a modern chronometer that's known, that we could have done something like this. But some people have looked at it and said, you know, with that Antikythera mechanism, that computes it right there in front of us. If we were to put in certain variables and knew how to work the machine, it could end up showing you the differential of what you think that you're seeing versus what you're seeing, or what you would think that you would be at versus where you actually are at in relation to this concept. One of the many things that little mini computer does.
And it's that departure of a perfect sphere that is very significant to us, because without that, again, Earth's orbital stability would be non-existent. Okay, so we're going to divide this up a little bit. If we take this square degree of latitude north to south, longitude east to west, and we look very carefully down in the lower right-hand corner, you're going to see something. A little square. You see that little square? That represents 1 minute, 1/60th of the degree this way, 1/60th of the degree this way. So that's 1 minute of latitude and longitude. All right? We're going to take a closer look at that, and we will see that 1 minute then is 6,045.881 north to south, 6,087 east to west, which is what we expect. The east-west should be a little bit longer. Okay, now we're going to do that. We take 1/4 of a square minute of latitude and longitude. Look at our dimension east to west. Look at our dimension north to south. And look at these two numbers.
Wow.
In fact, here's an accurate calculation. We take the 482.755 feet, which is the height, and what we discover is that if we multiply that by the number 43,200, which is one of our sacred numbers that we've seen right there, 43,200, it shows up in the Vedas and the Sumerian king lists, etc., etc. If we multiply the height of the pyramid by that number, this is what we come out with, 3,949.83 miles. And notice the difference between the pyramid, which I call the standard polar radius, and World Grid System 72 is only 313 feet over the entire size of the Earth.
Only 313 feet over this entire size of the Earth. And the bulge that happens just with high tide, low tide situation can be greater than that. So if we took 10 more measurements of it, they're all going to be off. It's not like we're going to get two exact ones in a row unless that bulge is in the exact same spot, and the sun also is in the exact same spot at that same time. And then we would just be looking at variant of a bulge, wouldn't we? So how close did they get here? Well, 313 feet versus the entire radius of the planet. That's pretty freaking amazing. The difference between a modern satellite and the ancient Egyptians at the earliest of dynasties. I've also shown, though, I had people say, well, the Sumerian ones aren't aligned. So I picked one out that they had a paper on showing this, and yeah, it's aligned, and this, that, and the other, and it's this size, and that height, and all these things. They had it all figured out too. All portions of sacred geometry. It's like, yeah, the same type of thing. That was also figured into the bent pyramid and so on too. But let's get on and see if we can finish this pyramid part and get on to the next firework that's coming.
So we have essentially the pyramid being a scale model of the Earth, the northern hemisphere, at a scale of 43,200 to 1. If we take the pyramid, enlarge it by 43,200, its height, including the socle, now becomes the polar radius of the Earth within 300 feet of our satellite surveys. Then the two measures of the base are exactly the difference between the east-west difference and the north-south difference at a square minute at the equator.
Now, that's the size of a square minute, but also taking two sides of the pyramid's edge is the distance that the sun moves across our sky or across the surface of the planet in a second. He's going to show that also.
Now, the skeptic and the reductionist would dismiss this and say, it's just a coincidence, you're just playing with numbers. And I would say, okay, you can believe what you want, but it's there. The numbers are there. You can take the surveys of Egypt by Cole. You can take the geodetic surveys. I didn't make those numbers up, or I didn't fudge them. And what you discover is that when you expand it by 43,200, which, if the number was just some arbitrary number, but it turns out that the factor of expansion turns out to be one of the critical sacred numbers within the ancient systems. And so here we have the pyramid now enlarged by 43,200 times. And another way to think of it is if we go back to this diagram right here, you'll see that as the Earth turns, every half second, it's going to turn this far. So it means that every 2 seconds, the Earth, if you're standing on the equator, in 2 seconds, the Earth has turned 143,200th part of its total orbit. So if you're standing on the equator, in 2 seconds precisely, the Earth has turned a distance exactly equal to the distance around the base of the Great Pyramid.
So if the sun had a stick that made it all the way to us and it was touching our planet in some way, or a laser light going onto it, it would take exactly 2 seconds for it to draw around the whole pyramid, or a half second to do one side. Figured on the same grid pattern that we use today, people.
Now you can dismiss that as being coincidence, but the numbers don't lie. They're there. And so when William R. Fix was saying that someone somewhere thousands of years ago was able to measure the Earth with great precision, and I haven't, of course, elaborated upon all the details of this. I'm trying to give you the overall picture of how it might have worked. Referring back to our geodetic data, if we look at the various ellipsoids that give the polar radius, and then we take each of those polar radii, going from all of these ellipsoids down the Clark ellipsoid has been the one of 1880, has been the one used in the United States for all non-military and non-NASA related measurements. We still use on a day-to-day basis. If you take a topographic map, and you're going out like a 7.5 quadrangle, and you're going out navigating with a topographic map put out by the U.S. Geological Survey, they're using the Clark ellipsoid right there. But you'll notice that when we take these various polar radii lengths in feet and divide them by 43,200, you can see the numbers we get right here. Remember, the height of the pyramid is estimated at 482.7575. So looking at this, what you'd see on here, which one would be the closest? Well, you notice it's come out very, very close to the satellite surveys. Given that it's very and see, when you got to ask yourself, well, why is there a difference between the satellite survey of 72 and the satellite survey of 80? Well, if we did another one again with as high a degree of accuracy, we would discover there's still going to be a discrepancy. And the reason is that the Earth spinning through space, there are various tidal forces working on the Earth which are constantly causing it to distort its shape by up to 2 or 3 or 4 or 500 feet. So we never would be able to get more accurate than 300 or 400 feet because the Earth itself is changing shape. And if we were to measure it every year for the next 10 years, we would get 10 different numbers. They'd all be very close, but they would deviate somewhat because the Earth itself, there are tidal bulges. Where's the moon relative to the Earth? That's going to affect. If the moon and the sun are on the same side of the Earth, that will affect the shape of the Earth up to being several hundred feet measured over the diameter of the Earth. And so it is not amiss to say that the pyramid enshrines a measure of the Earth that could be considered as accurate as those determined by modern satellite surveys.
Let that sink in for a second, people. It's something people have found, and then they turn around and they try to dismiss things like this. And it's like, well, we've got about 6 examples here. And we can show that all of these things are connected to the sacred geometry and stuff that's hooked up with all these other people. Oh, no, you're talking about white supremacy now. No, I'm talking about how white people did all this stuff in ancient times, and that they knew a whole lot more than we ever giving them credit for. In fact, you can turn around and shove it right in their face, and they turn around and try to dismiss it. And usually you'll hear them going off and start talking about alien possibilities, because that's so advanced. There's no way those Caucasians were doing that type of thing. Well, here it is right here. And like he says, you know, you can try to dismiss it, but here's the numbers. Look at them yourself and then tell me there's nothing there. Turn around and try to tell me, well, it's 313 feet off, so that shows you that they were wrong. Whenever that bulge difference will just wipe that off too. Something that you can't dismiss. I think it's one of the more incredible things they figured out about ancient Egypt here, and it shows you something. It's reason number 1744 that we know that these were the Aryan type people that were doing all this, because they're the ones that carried this information around the planet and utilized it in many places, which a few he's going to end up talking about here shortly.
Of that. See, that's the interesting part. Because no primitive culture, using the method of Eratosthenes in about 300 BC in Greece, he measured the Earth and was generally considered to be quite accurate, because he was able to get the circumference of the Earth within about 500 miles of its actual measured circumference. I
remember seeing this on Carl Sagan's Cosmos, and he talked about how he did it and had a piece of poster board bent on it. And he goes, well, if it's not bent, they'd have the same thing, but they did have a measurable shadow showing onto it. But of course, if you're measuring a micro shadow, that thing's not exactly plumbed or this, that, and the other, you could be off by a small amount. Well, he was apparently only off by a small amount, because he's within 500 miles of the actual surface of the Earth there. And people look at that to this day and go, that's just incredible. How do you do that? How do you do that? No. That pyramid that's right there by the Library of Alexandria, not too far away, that thing's showing you something that these people were much more accurate. Here's another one of those cases where they were more accurate in the past than they are in the modern time. And it apparently took modern satellites to get the point of getting close to back to the number and beating the surveys.
Using the methods available to the ancient Greeks, you see, and he was considered to be the first to measure by basically putting a stick in the ground and measuring the angle of the shadow on the longest day of the year over a couple of successive years. That's actually an exercise we do in the sacred geometry class, because it's very interesting how he did that. But he was considered to be, pretty proficient, because he was able to determine that the size of the Earth was, the circumference of the Earth was, 25,000 miles, when it's generally considered to be about 24,800, depending on where you measure. So he was, maybe within 50 miles of the actual dimension of the Earth. But
well, the measurement here at 24,901, it's 99 miles off, less than 100 miles off. Continue.
Nowhere near as close as the pyramid would have been. So again, even if the pyramid was built 4,200 years ago, you got to say who 4,200 years ago had the technology to measure the Earth with that degree of accuracy. Now,
and you don't want to hear the word Aryans or white supremacy or anything like that, but there is one people that were doing all this when other people were still primitives and hiding around in jungles and places, or had mediocre stuff going on. The heralds of civilization, and it happened everywhere. And if you don't think there are blue-eyed people connected to this or anything like that, like they keep trying to push on you, just look at what genetics has ended up showing us, and then look up blue-eyed Egyptian statues. And you'll actually see the earliest dynasties around the time building the pyramids, and they'll have crystal blue eyes. Then you look at red ochre males and pale females, and you're like, what's that? Well, that's the way it was drawn from ever back when. In fact, even through the Renaissance, women are very pale and so on like that. They used to even powder themselves with chalk to enhance that effect. But in reality here, what we're looking at is something that ended up getting traveled around the world quite a bit into a lot of people, and every people that we're looking at that are connected to this and the sacred geometry were also connected to these ancient Proto-Indo-Europeans. Just like all the linguistics, all the way from deepest India and their linguistics all the way up to the ancient Celtic languages and Irish and so on like that, it all works in together. Well, once you find out that the ancient Irish used to be in the middle of the world there, or around the Mediterranean for a period of time in Anatolia and so on, that'll make more sense. Once we find out Proto-Indo-Europeans moved and a large portion of them came over and made the West Europeans, that makes a double connection there. Whether we're talking about the Yamnaya culture, or if we're talking about the corded ware people, or people like that, the bell beaker cultures, and so on. They want to separate them all in different names, but we're really looking at variations on the theme of the exact same people, aren't we?
Now, that we know of, nobody 4,200 years ago did, or how they would have done it, we don't know. But on the other hand, if it turns out that the pyramid could be much older, it leads us back to the, going back 10,000 or 20,000 years. This to me is one of those little, sort of like the little crack in the dike, that if you don't keep it plugged, the whole edifice of contemporary knowledge could get swept away. Because
well, once we get deeper into the Göbekli Tepe and the Tastapeller sites, and the 14 and the earliest empire that we can find on Earth that comes from right around the end of the Younger Dryas, if we could find some people that come around just before that. But of course, so much happened during that time, it almost took the little blackboard you got behind you and just wiped everything off. And if you could make any words out anymore after somebody did that, it'd be pretty impressive. Well, especially if everybody's trying to dismiss this concept. Once we got Göbekli Tepe going on, I think people are going to have to make that extra step down. Now, eventually they will. But you can see that they're still at the point of kicking and screaming and trying to talk about how, well, they were hunter-gatherers, I guess. I can't have any agriculture with this. So hunter-gatherers were capable of doing everything that we said that they couldn't. That's their current stance on it. Let's continue.
We can't acknowledge that somebody 10,000 or 20,000 years ago was scientifically sophisticated. That was the days of Cro-Magnon man and Aleut living in the cave and so forth. Cavemen, which is a silly idea actually. Yes, I'm sure people did take refuge in caves,